So some of you might have some questions around the difference between the answer report and the sensitivity report. And as you know, once you generate the answer report, which we're all familiar with, for example, if I open something like this, this is one of the examples from Module 2, the allocation model, where it shows the different set of variables that we try to find, the decision variables, and what's that production plan solved by the solver. And we do have these coefficients. We call them the objective function coefficients. Remember these terms. And these coefficients that we have, we're using the sum product, taking these coefficients multiplied by this production plan, coming up with the objective function. Taking into account a set of criteria, or what we call them constraints. We know that we have constraint of fabrication, assembly, machining, and wood, as well as we want to stay below certain quantities in terms of demand. Sometimes the exercise asks to stay below. Sometimes they ask to provide a certain quantity, so you have to stay above that certain quantity. Regardless what the exercise is about, the way you see this is set up in this fashion. As we talked about in the past, that your constraints provided from the exercise go on the right-hand side, and then the left-hand side is usually, or most of the time, is a formula. And that formula basically uses here some product and takes these requirements, 4 hours of fabrication to make a chair, 6 hours to make a desk, and 2 hours to make tables. And what we're saying is, using this formula, we'll try to make sure whatever solver comes up with as far as this production plan or product mix, it has to stay below 2,000 hours that the fabrication department is capable to make. So that is the capacity for fabrication department, and so on and so forth. This is how much wood we have in square footage, and this is the way we write the demand quantities in order to meet our demand requirement or stay below certain demand requirement, whatever this is. So when we set up something in this fashion, let me take this off. When we set it up in this fashion, as I remind you all, in order to make things much easier, make sure you have the decision variable category, the objective function category, and the constraint category. So everything is broken down in 3 modules, and that is, again, emphasizing and stressing on the modularity piece that helps make things very organized and neatly set up for you. So now that you have your model set up, you go to Data tab, Solver, and then you set up your objective function. We want to maximize profit by changing these 3 variables and making sure that these constraints, these left-hand side, stay below our constraints, which are the right-hand side. Make sure that this is checked, and using the simplex linear programming, because that's what we're using. Everything we're dealing with in these modules, allocation model, covering model, blending model, network model, all of these models are examples of linear programming. So once we select that, we click Solve, and now what you're interested to see is that Solver found a solution. All constraints and optimality conditions are satisfied. What you do is you make sure you select these 2 reports, answer and sensitivity reports. This is how you generate those. You just click here, and then you click here again, and then you should have both of them selected, then you click OK. Now, when you look at the answer report, what you're interested in looking at, so I'm going to pull up this PowerPoint presentation. I'm going to set it aside so you just get an idea. This is one way you could make yourself a summary and make things much easier for you to grasp as we move forward. So, for example, I took snapshots for you guys to see what we're looking at. We have 3 binding variables. And what we mean by these binding variables, as you can see here, machining, desk ceiling, and table ceiling. These are limiting the optimum solution, or the profit in this case, from going any higher. And what we see here is a 0 next to the word binding, meaning that there's 0 slack. Those that don't have a 0, meaning that there's still slack in those and they're not limiting the profit in any sort. We call those non-binding variables. Anytime they show slack, they're non-binding. Pretty simple. So even though we change these variables or we increase these constraints, it's not going to have an effect on the optimum solution. Let's try that. I come here. We know that this variable, fabrication, is non-binding variable. So I can increase this, hoping that I can increase my profit. Let me make sure that this is set up right, so you could see easily that this is in dollars. All right, so I increased this from 2,000 to 2,500. I'll run it, and guess what? That value didn't change. Nothing happened because it's not a binding variable. But if I change the machining hours and maybe I hire more people or I add more machines, guess what? It will impact the profit. Let me see. This is the old value. This is the old value, 434,656. And try to play with these things yourself so you can get a clear idea of what's going on. I'm going to change this now to 1,500. I added a small machine or I hired a part-time person, and suddenly what happens is when I rerun, guess what? This is our original value. This is what our new value is, increased by a certain amount. Okay? So this is what we use the answer report for, just to figure out what are the variables that are binding and what are the variables that are not binding and having a slack of a certain amount. Okay? Any questions about the answer report before we move on? Okay, so if we look at the sensitivity analysis or the sensitivity report, we have 2 sections. We have this first section and we have this second section. And we all wonder, how can we read this sensitivity report? Pretty simple here. I'm going to go back and pull this one out. And when we look at the sensitivity report, I just took again some snapshots. And what you see here, this is the first part. The first part right here, the variable cells. What it tells me that you know these coefficients, 16, 20, and 3,000. This is where they're coming from. Okay? There's $16 to make on the chairs, $20 to make on the desks, and $30 profit to make on the tables. That's what we call them, the objective coefficient, right? And what we're saying is these values can vary. Like, for example, let's take one at a time. For the production plan of chairs, a $16 profit can vary, or it can increase by $14 or decrease by $16, and will not change the product plan. It will not change this. Let me put the numbers back where they were before. 1440. Let me just make sure that everything is back. Let me just rerun this, get things back to normal, and then we can look at it. So if I change, what we're saying is if I take this value, 16, and I increase it all the way to 30, or decrease it to 0, I will not be changing this production plan, but I will be affecting the objective function. Let's do that. Let me change this to $25 profit. Okay? And I run my solver. Look what's going to happen to this value. It will change. But look at this plan. And what I'm going to do is let me copy this. Let me paste it here. And let me copy this. Let me just paste it as text. So we have some control data to compare to. Now I changed this to 25. I'm going to rerun solver. Let's see what happens. See that? The production plan did not change. It might potentially affect the objective function, but in this case, it would not change. Okay? Let me see if this is it. Okay. What is it saying about the second one? The second one, it says it can increase to infinity, and it will not change the production plan. Let's do that. Let's make this one 120,000. See what it did to the objective function? Let's see if it affects the production plan. Nothing. See, that is an example of understanding the first part of the sensitivity report, saying that no matter, so this one, if it increased all the way to infinity, or it decreased by 9.33, it will not affect the production plan that we have. Let's do one more example, but this time we're going to decrease this much lower than the allowable range for decrease, which means I'm going to go, instead of going down to 10.77, I'm going to go all the way to maybe 5. Let's see what happens. Let's compare this to this in 1 second. I'm going to put the values where they were. So this one was a 20, correct? Let me make sure. It was 16, 20, and 14. Or no? Yeah, I think. Let's just do this. This is 25. Let's leave it at 25. And let's move this down to 5. Is that right? It was 16, 20, and 3,000. 16. It was 20. I changed it to 5. Okay. All right. I'm going to rerun this. Let's see what happens to the production plan. There you go. It did affect the objective function, and it did also affect the production plan. So this is what we mean by this section here, is that I am allowed to change these variables according to this range. And whenever you see something like this, that means infinity. So the way I will write it a little bit differently than how it's written here in this report. What I can do is I say minimum profit, maximum profit or minimum value, let's say, because the objective coefficients could be different every time. They can't be just profit value. It could be other things as you're going to explore going forward in the next modules. And in this case, what I could do is increase 16 by 14 and make it 30. In another way, I can just do equal 16 plus 14 and do equal 16 minus 16. That's the decrease. And I know it can vary between this range and would not affect the product plan. And I can do the same thing here. This is infinity. Increase, sorry. So I have to move it here. And the decrease, I can just do this, multiply minus this, and it will tell me that I can vary this second coefficient between 10.66 and infinity, and it will not affect my production plan. So that is the first part of the sensitivity analysis. Now we'll touch base on the second part. But before I do that, let me see if there are any questions. Are there any questions so far? The first section of the sensitivity analysis. Okay. If there are, I'll be looking back and forth to the chat room and see if there are any that pops up. But we'll move on to the next part. And this part right here, what we have is what we call it the shadow price. And what is a shadow price? The shadow price is that now we're looking at the constraint section, remember. We're not looking at this portion right here, the coefficients of the objective function, but instead we are looking at right here the constraints section mainly, and these are the values we'll be changing to see the impact on this and this. Okay? So what we're saying is, if I come here and I change this constraint right-hand side, this 2000, will it have any impact on the objective function or my optimum value? Well, from here I can tell that these variables are not binding just by looking at the shadow price. And if I compare them to the answer report, not binding, not binding, not binding, not binding. The first two and the fourth and the fifth. The first two and the fourth and the fifth. It has to correlate. Okay? The ones that are binding, it's telling us that it has some sort of a shadow price. What is a shadow price? A shadow price meaning that if I take this constraint, 1440, and I change it between this range, it will, by 1 unit, it will increase the objective function by 1.77. Okay? And let's try that. Another way I will write this down is, so min value, max value, and I would put it the same way I did. I'm just going to do it for the ones that are binding. I'm going to take my right-hand side value and decrease it by 144. This is my min value. My max value, I'm going to take this plus the allowable increase. Now this is my range. Min value and max value. It can vary between 1296 and 1656. As long as this constraint varies within this range, we're going to have an incremental increase of 1.77 on the objective function. Let us do this. Let us try it. What I'm going to do is I'm going to add, let me get rid of this. And let me just do something here very quick. I'm going to add 1 to this right-hand side. See, we are looking at this right-hand side of the constraint, which is 1440. I changed it to 1441. Let us see what happens to this. In fact, what I'm going to do here is I'm going to make sure that the values are set up properly, or the profit values are set up properly according to this: 16, 20, and 14. 16, 20, and 14. Okay. I'm going to rerun this very quick. Just give me 1 second. Okay. I'm where I need to be right now. 4,672. Let me compare that. Of course, it's not shown here. Sorry. But at least I know that everything looks perfectly fine. What I'm going to do here is I'm going to write this number down, 4,672. I'm going to keep it. This is the original value. Now I'm going to change this constraint by 1. Let's see what happens. I'll hit OK. What I'm going to do, I'm going to add, see what I'm doing here? I'm showing you the decimals. What's the increase from original to the new? If I do this minus this, 1.77777778. That is exactly what we just came up with. An increase of 1 caused an increase of 1.7778 on the objective function. This is what we mean by the shadow price. An increase of 1 increment of the constraint would cause an increase of the shadow price amount on the objective function. So the question is, if I increase this right-hand side of 120 by 1, what is that going to do to my objective function? It's going to increase it by 9.3333. We can try that. Let me just put this back to what it was. Let me run it very quick. Okay, it's back to the original. Right? Now let me add 1 here, the right-hand side constraint. Let's see what happens. Okay, 9.3333. So this is how Solver comes up with this shadow pricing. And it's very important to look at the shadow pricing because it tells you the priority. If you would prioritize which ones to increase, you will definitely go after the one that gives you the highest shadow price. This helps in the decision making. Does it make sense? But if I go outside of this range, will the shadow price still adhere? Well, let's try it. I'm going to go below this range. So you see this decrease of 144, it gives us 1296. So I'm going to go to 1290. So let me put this back. I'm going to go to 1290. I'm going to run the solver again. 1290 equal this minus this. It gave me minus 276. 276. Now, this no longer applies. See that? It doesn't apply anymore. If I change it to 1297 back within the range, 1297, look what happens. Hold on 1 second. So this is equal this minus, equal this value minus this, and it's 1296. And I went right in between that value. So we put 14, 40, 14. Oh yeah, that makes sense. Sorry, my bad. Because, my bad, I'm going to put it back to where it was. So when we did 1297, we reduced that value by how much? 1440 minus this. We reduced it by 143. So what happened is we take this value multiplied by 1.77778, and that gives us this value. See? This is the relationship between reduced constraint, impact on objective function. If we reduce it by 1, it changes it by 1.77. If I reduce it by 2, it will change it to 3.5576. If I reduce it by 3, see, and it continues. If I reduce it by 144, or 142, or 143, it gives me this value that we just got here. And that's exactly what we did. We reduced it by 143 from 1440 to 1297, and it changed from the original to this value, which is a difference of 254, which you could find easily by taking the shadow price times the amount of value that you changed. Does that make sense? Let me see if there are any questions. Will the binding ones always double after the initial value? They don't double. They always change by the amount of the shadow price. So if you, like we did, by changing by 1 increment, it changed by 1.77. If we change by 2, you take 2 times the shadow price of 177, and that becomes 1, you change by this amount. Reduce or increase, doesn't matter. If you decrease, let's say you do -1, it will change by -1.77. If you do -3, it will decrease by, that's why we're seeing this one as a negative value. Okay? And so on and so forth. Is it pretty clear? Exactly. That is exactly right. Perfect. So enough talking about the sensitivity analysis, and I believe that you all can now be able to solve for the midterm. It should not be difficult. The questions are straightforward. The one thing that I emphasize on is when you're doing the midterm, the only symbol you're going to have in the constraint section is this. That's it. Throughout all your constraints. The reason why, because the exercise asks from you that there is a demand constraint there of 20,000, right? or 2,000, I can't remember. And then there is 1,600 or 16,000, I can't remember. This is the right-hand side, of course. Your left-hand side will have some sort of a sum product formula, right? Equals sum product on all of your constraints. Okay? And please make sure that this is the symbol you're going to use for the demand constraint. None of the symbols is going to be greater than or equal. None of them. So that should help you not get confused. I know when we talk about demand, I've been telling you guys that the demand, in order to meet the demand, you have to have it greater than or equal. But just for this exercise, there was kind of some issues with the data provided to you. So make sure, in order to come up with a feasible solution, to make this less than or equal symbol. Is that clear? I'd just like to hear from you guys that this is clear and you guys pretty much are aware of this, so you're not surprised once you see the results. The announcement page should have more information in that regard. If you still have any confusion or not sure what I mean by this, please reach out to me, or particularly through the general discussion. Good. So this is the one thing I want to make sure. Otherwise, everything should be straightforward. The decision variables should be 4 of them. You're going to have 4 decision variables. Okay? Your objective function, you might have revenue and costs, and you would have to figure out what the profit is, right? And then you could use the sum product to generate your objective function, which takes the profit or the array of profit. Sorry if this is not the same size. I'm just trying to write this quickly. I can't remember the exercise, so don't copy exactly how I'm writing it. I'm just telling you if that is the case. You know, you do some little calculation to come up with the profit, which is the revenue minus cost equal profit per unit. Then you start on the constraint sections. So your objective function could be written here, which takes equal sum product of profit with these values. I assume that's what the exercise is asking for. You lay all your constraints here. If they're asking you have some sort of constraints, whether it's fabrication or wood or anything, and you write the hours or the quantities on hand, whatever. And then, of course, on your constraints, you're always going to have a left-hand side. You're going to have the symbol. You're going to have the right-hand side. The right-hand side is where all your constraints, you're going to write all your constraints here. 2,000, 1,600 quantities, this is my demand. And for this case, like I mentioned to you, everything should be less than or equal. And the left-hand side is all sum product function. And all you're doing is just taking this section against this and making sure you put an F4 to make an absolute and close the parenthesis. And the rest of it is just you drag the formula across all your constraints. So I can drag it up or down, so now I have some products, whatever I write down here. If I'm dealing with some, let's say, demand requirements, every time I'm dealing with a demand requirement, for example, if this is asking for a 64 gigabytes, and I have it broken down into 2 decision variables. This is make in-house. This is buy from subcontractor, if that's the case, for the 64. Right? then I know I'll put a 1 here, 1 here, because this represents the 2, and they have to meet this quantity, regardless of how the way I make them or the way I purchase them. I need to meet a certain amount of demand. Except here, like I said, and I always repeat this is an exception of putting a less than or equal. But usually we should put greater than or equal. This is just a one exception that because we have some errors with the exercise provided to you, and if you put a greater than or equal, you're not going to achieve a feasible solution. We're going to correct that going forward, and hopefully in the next term, this is not going to be an issue. And does this click now? Pretty straightforward. No, I would not write it that way, Rendell. I will write it exactly the way you see it here. Let me take these off. You will have some constraints here, and then you're going to start on the demand constraint at the end. And for the demand constraint for 64, this is the section, let me take this off so you know. Make in-house, and then you have buy. Then you have 32 gigabytes, make in-house, and then buy. You will have 1100. For the 32, you would have 0011. And then you have the sum product function here, right? If the 64 gigabytes, they're asking for 2,000, then it goes right here. If they're asking for 1,600, I can't remember what the exercise asks for. But this is straightforward. Don't split them because that's not what they're saying for you to do. If you start making up things, then you'll definitely distort this optimization model. Does that sound right? Great. Okay, great. So pretty straightforward sensitivity and answer reports. You guys should be very familiar with them. Please play with the numbers. Try to simulate different things and see how it impacts your model setup. That is pretty much everything in Module 4 that you should know about. And reading the chapter will give you more information in terms of other solutions in the optimizer, solver optimizer. But some of that stuff will not be touched on in the exercises. Are there any questions in Module 4? Now we can start on Module 3 for those of you who are still having some issues. If you feel comfortable with Module 3, you can definitely drop out of the line, and you don't have to stay if you don't have any further questions. And if you feel pretty good about Module 3 and 4, then best of luck to you. But for those who still have problems with Module 3, please stay around, ask questions. This is more of an open discussion, and we can run through it very quick. If there are no questions, I have some models for you to run through, and hopefully that will clear things for you. Good. I'm glad to hear. So if no questions, I can go ahead and cover the things that I have on my plate. Please